Processing includes built-in functions for organizing your sketches called code blocks. In this lesson, I'll show you how to organize your sketch into code blocks and teach you how the two most common code blocks function. Additionally, I'll teach you how to create your own color palette stored in an array. Finally, I'll introduce the random function and show you how random numbers can become one of the many artist tools you can use in processing. So, let's jump into processing and we'll start sketching. Okay, so here we are in processing, and I've created a new sketch, and I've went ahead and just put the opening comment, which is what we're going to be talking about in today's lecture: code blocks, arrays, and color palettes. Code blocks are used to help break your code up into distinct sections, allowing the compiler to execute some parts of your code multiple times. In this lecture, I'll be covering the setup code block and the draw code block functions. The setup function is called once the program starts. It's used to define initial environment properties such as screen size and background color, and to load media such as images and fonts as the program starts. There can only be one setup function for each program, and it shouldn't be called again after its initial execution. So to create your setup code block, you're simply going to type first what the code block returns. Now this code block returns nothing, so we're going to type void. Next, you're going to type the name of the code block, and this is our setup code block, and then we'll open and close the argument parameters, and we're not going to pass any arguments into this, so we're going to leave that empty. Next, we're going to use the curly brackets to outline where our code will be. Every time you use a curly bracket in processing, you're going to need another curly bracket to close off your code, and any code that's going to run during the setup function will exist in between these curly brackets. It's good practice to space out your curly brackets, and each time you create an opening curly bracket to immediately create the closing curly bracket. So I'm going to space this out like so, and then our initial size and background color will go inside of our setup code block. Then we have the draw function. The draw function continuously executes the lines of code contained inside its block until the program is stopped or until the no loop function is called. There can only be one draw function for each sketch, and draw must exist if you want the code to run continuously, or if you want to process events such as the mouse. So I'm going to set up the draw code in a similar way. I'm going to type void because it returns nothing. Then I'm going to type draw, open and close the arguments. We won't be passing any arguments initially. Then I will place my curly brackets as well. So the code that goes inside here, these are the elements to be drawn to the canvas. Now, let's set up the size and background color of our canvas. So our canvas size is going to be 800 pixels by 600 pixels. And for the background color, I'm going to introduce a new variable type, and this is the color variable type. So to declare a new variable, you first type the type of the variable. This is going to be of type color. Then you give it a name. I'm going to call this dark brown. And then you fill the contents of the initial state of the variable. In this case, it's going to take the 6-digit hex code for dark brown. So I'm going to use the color selector to grab that. I'm going to use this dark brown here. Copy this hex code right here, paste it right here. Now, when I type background, instead of putting in the hex code or needing to look up the hex code, I can simply type dark brown and then close that off. So I'll go ahead and close the color selector, and let's take a look and see what we've got so far. Great. So we've established a new variable of color type, and we can use that variable here. Now I want to point out that there is a difference between global and local variables. Anything that exists within the curly bracket bounds of a code block is considered a local variable. What that means is that this variable can only be accessed or modified from within this block of code. Now let's say I wanted to use this dark brown in my draw function. Well, then I'd have to create instead a global variable. Global variables are placed at the top of your code. I'm going to go ahead and paste the dark brown color variable there. Now, it's still there, and when it's called upon in the background, it should still work. But this also allows me to call upon the dark brown color variable in my draw section. So let's just make sure that the code is still functioning correctly here. It should be a dark brown background. Great. Let's move along. For the draw section of our code, we're going to be creating first a rectangle. Then we're going to do several different modifications to the rectangle as the draw function repeats over itself. So first, we'll set up some initial parameters and give ourselves a rectangle on the screen. So first, I'm just going to place this at the center and take a look at what we're working with here. So I'm going to go width divided by 2 and height divided by 2. And the initial parameters, I'm just going to type 250 by 250, and let's just take a look at this. Okay, so here we have our rectangle on the screen. There is a 1 pixel stroke that is black. It's a little bit hard to see in this video, and the fill is set up with the default of white. Also, if you notice, different from an ellipse, the rectangle, the origin of the rectangle is in the upper left-hand corner. So this is the rectangle's relative 0, 0 origin point, and if you notice, it's located at exactly half the width and half the height of the screen. So don't be thrown off that this rectangle is now what appears to be off-center. Okay, so we're going to make a few modifications to this rectangle. First, we're going to remove the fill simply by typing no fill and then pass it no arguments and close it off. Then I'm going to set up the stroke weight. And I'm going to put that at 5 pixels. And then for the stroke, I'm going to put in a temporary color, and this is going to be sort of a bright orange color. Use the color selector, grab my bright orange here, copy this, and paste this into the stroke. Okay, so let us take a look and see what that looks like now. Excellent. Okay, so we have our rectangle. This is sort of the template of what we're going to be working with here. So now, because the draw function, as mentioned previously, repeats until you tell it not to, what you can do is have it cycle through the elements of code within the draw function, and each time it cycles through the elements, you can have it modified slightly. And in order to do that, you need to create a variable which can store a value and then change that value each time that it iterates through the draw function. So to do that, I'm going to create a global variable called x, and it's going to be a floating point. So I'm going to put this at the top with my other globals, and I'm just going to write float x and then close it off. I'm not going to give it an initial value because I'm going to worry about filling it with changing values in our draw function. But I'm declaring it here first just to let the compiler know that at some time we're going to be working with a floating point called x. So now, what I'd like to do is use something called an operation function. I'm going to pull up the reference to talk a little bit more about the operators. So if you pull up the reference and you scroll down and look along the right side of the reference, you'll see that there are several different operators, each one of these listed here. These allow you to take a number and increment it, multiply it, subtract it, and other functions. And that way, each time the draw function is called, one of these operators will make a mathematic calculation and change the output of a variable. So how does that work? Well, let's set up a situation here. I'm going to minimize this. What I'd like to do is I'm going to take this rectangle, and starting from the left-hand side of the screen, I want it to move and redraw itself each time that this draw function iterates. So to do that, I'm going to say that the x function plus plus is the increment modifier. So this is simply going to take the value of x, and each time the draw function iterates, it's going to add a value of 1 to it. So x is undefined, so it's starting at 0. So it's going to count up from 0, and it will count up indefinitely. So let's take a look at how that can inform our drawing by saying that the rectangle will start with x instead of with width divided by 2. This means that each time it loops through, it's going to replace the position of the rectangle at x and height divided by 2. Let's see what that looks like. We'll press play here. So you see now that processing is taking an initial value and then adding 1 pixel and redrawing our rectangle across the screen. Now, once it's off the screen, it's actually not done drawing. And let me show you what I mean by that. When you're working in programming, oftentimes you'll want to see how a number is changing as your code is being executed. And to do that, we can print the contents of whatever variable or whatever number we're working with to the console below. And to do that, you're going to use the print line function. And the argument it takes is whatever you want to see printed to the console. So I want to see how the value of x is changing as my code executes. So I've decided to put that in the print line function, and let's press play. So now you see below that x is counting up. And this is just changing the value of where the rectangle should be drawn on the page. Okay. So you might be asking yourself, well, how do we say when to stop? Well, for now, we're going to teach you how to use the constraint function. The constraint function allows you to constrain a value to not exceed a maximum and minimum value. So what we're going to do is we're going to reassign the value of x each time using the constraint function. And this is just going to check the current value of x, and if it's within the bounds, it'll allow it to continue to add on to itself incrementally. And if not, it's going to pause the increment here. So if I type x equals, then I'll bring in the constraint function. Simply type constraint and open up the arguments. Now, the first argument is what are we constraining? Next is the minimum value of the constraint. And last is the maximum value. So let's just type 250. And so this is going to iterate through 250 cycles, and then it's going to stop at 250. So let's take a look at that here. So here we go. We're counting up here. We've got x output. As soon as it reaches 250, it's going to hold tight there and stop. Great. So we've given it a little bit of a boundary here. And actually what I wanted to do is I want to be able to draw the length of the width of the screen, and also I want it to go over the screen and just past the edge. So I'm going to do width plus 250. And I'll run this and make sure that it's just running off the edge of the page. Great. That looks good there. Okay. Now, what we were getting is a big line. It was drawing a big, thick block, because our rectangle is being drawn so close to itself that it's merging into one new shape. Well, what if we want to preserve the bounds of the rectangle? Well, instead of adding by 1 each time, instead we can change the value that we're adding by. Now to do that, we're going to use a different operator function. And in this case, we're going to use the AddASine function. AddASine works like this. First place your variable, then press add the plus sign, the equal sign, and then the number by which you want to increment each time. So if we were incrementing by 1 before, now we could increment by 2, 4, 6, 8, any number that we want. In fact, let's start with 16. So this is going to take every 16 pixels and redraw one of our rectangles. Let's take a look at what that looks like. Excellent. So it's redrawing our rectangle on top of itself every 16 pixels. It's an interesting shape. Okay, and we can space it out even more. Let's try 32. Great. That's an interesting pattern, but there's more that I'd like to show you here. Now we'll take a short break to see how things are going with a brief quiz. So at this point, what I'd like to do is create our first array. An array is a list of data. It's possible to have an array of any type of data. And each piece of data in an array is identified by an index number representing its position in the array. And the first element in the array is always 0, and the second element 1, and so on and so forth for however many elements that you have. So for our array, what I'd like to do is use our array to create a color palette. This is going to be a sequence of colors which can be called upon as one entity. So creating an array is a lot like creating a variable. Well, first you type the contents of the array. So this is going to be color array. Then you're going to use square brackets to indicate that this is an array type. Then you're going to give your array a name. I'm going to call mine palette. And then you're going to fill it with the contents of your array. Now at this point, I want to introduce you to a new tool for creating color palettes. This is a tool that's available on the web, and it's called Adobe Cooler. And you can get there by typing in cooler.adobe.com. And from here, you can create your own palettes of 5 different colors, and the Cooler will output the hex codes, allowing you to copy and paste these into your processing program. You can create your own, and you can also explore other palettes that have been made by other users. Now I have one that I've already created here. It's this 5-color palette here, and what I'm going to do is simply just move this window down so I can see these hex codes here, and then I'm going to grab them one by one and fill my array with each of these. Make sure that you add the pound sign for each one of these colors. So to close your array, you're going to close your curly brackets and then end with a semicolon. And then each one of these colors can be accessed by their address. So this is accessed at 0, 1, 2, 3, and 4. So it starts at 0 and it ends at 4. That's something important to remember that can cause a little bit of confusion later. So now, instead of using this dark brown color, let's say I wanted to use the first entry of the palette, this first color here. I would type instead palette, and then in square brackets, I would put the index number of the color that I wanted to use. If I wanted to use 0, place 0. Let's take a look at that. Okay, so this is very similar to the dark brown color we had before. So let's take a look at a few other colors. So this would be 1. Okay, and so on and so forth. We can change these colors throughout. I'm actually going to leave this one set at 0. I'm also going to remove this print line code, as we already know what X is doing. We don't need to see it continue to print to our output. It can be a little distracting. So we've set up our array of our color palette. So now what I'd like to do is to use the random function to allow each time a new rectangle is drawn for it to be a different color. I also want to sort of move the rectangles around the space along the y-axis using a random number as well. So the first thing that I'm going to do is use the random function to decide the y value of each of these rectangles. So I'm going to remove this height divided by 2, and to use a random number, or to call upon a random number, you type random for the random function, and then you open and close your arguments. So random outputs a floating point number, and whatever number you put here, for instance, if I put 50, it's going to select any random floating point number between 0 and 49.999. So if I need 50 to be one of my numbers, then I would have to change this to 51. But actually, you can put other things inside here, like I'm going to put height. So this will place these rectangles randomly throughout the height of the screen instead of all in one line. Let's take a look and see what that looks like. Excellent. So we have our rectangles now being drawn randomly throughout the space. So now what I'd like to do is to create a new variable which is going to store a random number, and then that random number will be called upon when drawing the stroke of these rectangles. And that number will allow the one random entry from our 5-color palette to be selected when drawing our rectangles. So to do that, I'm going to make a local variable inside of here, and I'm going to call that R. So it'll be of type float, R, and I'm going to say it's equals random function, any number between 0 and 4.99999. So I'll put 5 there. Close that off. Now, when I want to call upon a color from my palette, I'm going to type in palette, and then inside of these brackets, I'm going to put R. But it's going to cause an error, and I want to demonstrate that and talk about why. So it's telling me cannot convert from float to int. So to dial up the address of one of our entries in our array, we need to pass an integer, but the random number outputs a floating point number. So we have to do a quick on-the-fly conversion of R into an integer when we call it here. And to do that, instead of simply typing R, you're going to type int, and then in parentheses, then you're going to place R. This says that convert the contents of R into an integer and then place them throughout the canvas. Let's take a look now. Excellent. So this has allowed us to draw several elements of rectangle functions and place them throughout our canvas. Now I want to do one last random function, and that is I want these shapes to become random so that they will be random different types of rectangles instead of all the same size square. And also I'm going to change the stroke weight to be a random number between 0 and 19.999, like so. So let's take a look at this now. Excellent. So this has allowed us to generate this abstract and interesting piece with a similar color palette and similar shapes, but we've done very little code relatively to create so many objects and so many diverse objects. Okay, so in this video I've shown you how to work with code blocks. The setup code block, which is executed once and first, and the draw code block, which is iterated through while your sketch is running. Then I also showed you how to work with local variables, variables stored inside of your code blocks, and also global variables, which are variables accessible to any code block throughout your program. Then I showed you how to create an array and populate it. In this case, we created the color palette array. Creating your own color palette is easy, and using tools like Cooler from Adobe just makes it easier. Then I showed you how to work with the random function. I showed you how to constrain variables, and I also showed you how to use different modulation functions on your variables to change them as they iterate. In our next video, we'll go a bit further by working with loops.